It's
Meeting
recorded?
is being
Yeah.
recorded.
Oh, you must be. Oh, so you're actually the host. Okay, I
No,
didn't
no,
have those
you're
rights.
you're a host as well. But
Oh,
we'll sort
okay.
it out later.
I think it's whoever logs in first. Okay. I'm going to say hello to Michael, who has joined us here today, but a lot of students hopefully will be coming on to have a look at this recording. Just to let you know, um, we're supporting our students by offering a half an hour lesson or so on a Tuesday and Friday. We'll say that the normal online classes that parallel the learning management system will be running on Monday, Wednesday, but we have a very wide range of abilities in our Year 7 maths classes, so we're offering support, and some people actually might need extension as well, and it's important that you talk to your teacher about that. So that's either me or Jacob. It'll be an opportunity for you to interact with me on a Tuesday and Friday. You can raise any questions that you've had from the Monday, Wednesday lessons. Depending on how you're coping with those, you might just do the Tuesday or Friday lessons. So what I've actually put together today is a document that I'm going to email to a number of students who have been highlighted as needing support. And we're going to ask that you actually work through that. And I can see that Aiden's arrived. Aiden's in my class, so welcome, Aiden. And I only just started it at 10:20, so don't worry about that. So this is my very first slide, Aiden. So welcome. Because I'm allowing people to interact with us today, you are welcome to have your microphones on, but I will remind you that particularly because your microphones will be on, remember to be respectful to everybody in the room. No question is a silly question. There's to be no put downs or anything like that. But sometimes you just might want to talk. Sometimes you might not want to talk, but that's fine. All right, enough of me talking. Let's go. So what do I want to do today? I think fractions is scary thing for a lot of students. Okay. To be honest, I just did a lesson with my year 10s talking about fractions. And I did tell them that'll be the last time I talk about fractions. So you've been exposed to it a lot through primary schools, but maybe something hasn't clicked with you and you haven't quite understood it. So I'm going to try and work through some of those fundamental ideas so that we can better understand how to work with them. And we're also going to have a look at some graphs that we've been. Jacob loves fractions. Yes, so do I. To interpret some graphs. So we're going to parallel our Tuesday, Friday lessons with what you're already doing Monday, Wednesday. But as I said, some students might just end up with the Tuesday, Friday classes. We're just checking it all out at the moment. Okay, what have I got? So the screen that you are seeing now, all of these slides are going to be emailed to you because this is your actual task that you're going to be doing. So I'm going to be working through some of it and then I'll be getting you to finish it off. Fractions are dissected numbers. That's an interesting way to look at it. Yeah, it's parts of numbers. It's parts of a whole. So yeah, I would agree with you there. So I'm just going to turn on my lovely annotating pen. And I don't want yellow. I think I want red. Maths teacher, I like red. And it's a little bit slow coming up with my choices. Okay. Now, what we've got here, fractions, comparing and ordering fractions. Label the missing fractions on the number line. So we have that. We have a number line going from 0 to, sorry, let me do the top part. 0 to 1. So all the numbers in between sit along here. So it looks like I've got a fraction halfway in between. So it's no surprise that we would actually say that this is 1/2. And what number goes in here though? How can I write 1 as a fraction over 2? Anybody happy to type in there, or you can use your mic to talk to me? If I go from 0 to 1/2 to 1, how do I write that as a fraction over 2? Aiden says 1/2. Yeah, I've got a half here. So I can't also have a half on the end. Oh, don't even know where that blue one came from. Weird. How many halves are in one? 2. Yeah. So this says here 2 halves. So any number, like the number 1, sorry, can be written as 2 over 2 or 3 over 3 or 4 over 4. So any whole number can be written as a fraction. And a fraction just has a numerator on top and a denominator down the bottom. And we can split that up, like you said, dissect it if you like. So I'm just going to look at this one here. I'm going from 0 to 1, but this time I'm going up by thirds. So if I have a look at this, I've gone along 1/3, 2/3, 3/3. So here's 1/3, here's 2/3, and here's 3/3. So what we're looking at here is where these numbers sit. So I can see a half is bigger than a third, and a third is bigger than a quarter, and a quarter is bigger than a sixth. In fact, the higher this number down here, the smaller the fraction. If you think about your pizza, you've got one pizza, you've got 2 people eating it, you get half each. If you've got 12 people eating it, you only get 1/12 of the pizza. So the more people, the smaller the pizza. So the larger the denominator, the smaller the fraction. So as I said, this is going to be emailed to you. You can come back and watch this video. I filled in part of it, but I'd need you to go ahead and complete what's on that sheet. So before I go on to the next slide, and I presume I've still got Aidan and Brett in the room. Do you have any questions? Oh, sorry, Aidan and Michael in the room. Any questions before I go on to the next slide? No? All right. Because it's just the 2 of you in here this morning, yeah, I will be asking questions, and if you're comfortable, please answer. But because it's just the 2 of you, you might feel under a little bit of pressure, and I don't mean to do that. Okay, in order to move to the next one, I need to stop annotating. All right, what do we got next? So again, this is part of the document that I'm sending you. Are these statements true or false? Use the number lines above, so the one on the last page. So once you've got that, you might be able to use that to help you do this, to help you with your decision. Remember, the large end eats the larger number. Yeah, well, I like to actually use the words that we need to understand. Oh, I don't need that one. Very slow to get the pencil working. Clicking, clicking. Come on. I have to do it that way, perhaps. Here we go. All right. So what they're saying is true or false. Is a third less than? So this is less than. The one that looks like an L is the less than sign. And obviously the one that goes the other way is the greater than sign. So the question is a third less than a half? So we're just going to go back and have a, if I go back to the last screen, I have to unannotate. Is a third less than a half? Well, I can see that it was. All right, if you think about your cooking and if you're thinking about your cooking, if you had a third of a cup, it's going to be less than your half a cup. So annotate and back on. It's very slow to have to actually do that every time. Very annoying. So is a third less than a half? Yes, it is. So that would be a true. But what I'm going to talk about here is another way to look at it. As I said, I've got various levels of understanding in this class. So I'm going to talk about this in terms of equivalent fractions. So in order to do that, I've got a third and a half here. I can't deal with them when they've got different denominators. I need them to be the same denominators if I can compare them. It's like comparing apples and oranges. You can't do it. You want to be able to compare 2 like items, if you like. So when you look at the number 3 and the number 2, what do you think we should be changing the denominator into? I would like it to be the same. So the question you ask yourself is, what's the smallest number that 3 and 2 will go into? Are either of you able to tell me that? What's the smallest number that 3 and 2 will go into? $22. I'm interested to know how you came up with that. 23. Okay, it's interesting because you've just put the digits together. That's really interesting to see, Michael. The number 23 is odd, and so 2 won't go into it. And if we look through our 3 times tables, 3 times 7 is 21. We're not going to get to 23. So there's a misconception that you have there, Michael, that you just put the numbers together. What you can do is multiply the numbers together. So if I had have said 3, oops, I don't know why it does that, 3 times 2, I'd get the 6. So the smallest thing that 3 and 2 will go into is 6. 3 goes into 6 twice, so that's like 2/6. So 1/3 is the same as 2/6, and 1/2 is the same as, if I'm going to change it to a 6, how many 2's in 6 is 3, and 3 times 1 is 3. So now I can compare apples with apples. I compare 6ths with 6. Good. So 2/6 is less than 3/6 because 2 is less than 3. So remember, we can do this using the number lines. If we go back, we can see where those positions were on the number lines. But another way to look at it is to actually look at the smallest thing. In fact, if you're just comparing fractions, you don't need it to be the lowest common denominator. So just to have a look at the next one, if I want to compare quarters to sixths, I can't do it because they're not the same. What should I change the bottom to? I can look at the back to the last screen, but what could I change the bottom to so it would be fair? I've got a 4 and a 6. I can't change the 4 to a 6 because 4 doesn't go into 6. Now remember I said you could just multiply these? It's not the lowest common denominator, but certainly if I multiply 4 times 6, I get 20. Does that? 24? So I can change them both to 24ths. But if I change the bottom, I better change the top. So 4 into 24, how many 4's in 24? Goes 6 times. So 1/4 is the same as 6 on 24. How many 6's in 24? Is 4. But I've got 2 6's, so I better say 4 times 2 is 8. For some of you who struggle with maths will still be probably having trouble with your tables. I strongly encourage you. You know, a lot of those textbooks these days have the maths tables on the back. Have that in front of you. Have it on the back of the toilet door. The sooner you can recall those number facts, the easier you're going to find your mathematics. Once I've done that, I can see that 6/8 is less than 8 on 24. But just going back to the last screen, let's just compare where 1/4 was compared to 2/6. So let's just do that. Let's go back. Here's 1/4. Oops, I clicked on the screen. I can't do that. Here's 1/4, and here's 1/6, 2/6. So 1/4 would be less than 2/6. So it's really nice when we have it all on the same number line. Okay. Once you've completed your number lines, we should be able to put these from smallest to largest. So again, you could change them to the lowest common denominator. That would be a higher level, but feel free to actually just go back and have a look on that chart on the last screen that you filled in, and you should be able to rank them from lowest to highest. So I'd like you to have a go at that task when you get it. Any questions before I move on? I know I can go a little bit fast sometimes, but that's the beauty of a recording. You can come back and look at it in your own time and pause and recap what I've said. Okay, are these statements true or false? Let's have a look. 6/9 is shaded. So the thing about fractions is when you're comparing them, they have to all be the same size. So the fact that I've got a 3 by 3 grid here, I've created 9 squares. So each one is 1/9. So how many ninths do I have shaded? 1, 2, 3, 4, 5, 6. Is 6/9 shaded? Yep, I'd be putting true in that one. What about B here? It says that 1/4 is shaded. Is that true or false? If you could type into the chat box, that would be great. Have I got 1/4 shaded here? Is that true or false? Yeah, both of you have said it's true. Notice this is quarters. These were ninths. What have I got here? 1, 2, 3, 4. So there's still quarters. So can it be true that a third is shaded? True or false? A third is shaded. True or false? In the chat box, please. False. Yeah. I would agree with you, Aidan. I can see that I've got 4 and 2 of them are shaded. So I'd say a half is shaded and a half and a third aren't the same thing. Yeah. I think you can see it too, Michael. So I've left you with one there to do. And this one here, you need to colour the shapes. But this one's interesting because I'll put on my annotator. It's time to do that. All right. I have to do 1/3, but I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be easier if I had 3, but I've got 9. So how are we going to go about this? How many do I need to shade if I want 1/3 of them done? A couple of ways to do it. Aidan's saying 3. Yeah. For every 3, I'm going to shade 1. So I would shade this one and leave with 1, 2, 3. And I'm going to shade this one and leave 1, another 2. I'm going to shade this one. So they don't all have to be together, but I've shaded 3 out of 9, and we can simplify that fraction to be 1/3. So when we do our mathematics, we always like to simplify our fractions. So I'm going to leave you with these ones to do. So I'll be emailing this through to you both and others that haven't managed to come to our lesson this morning. Fractions of a collection. There is another way to find fractions of amounts. So what's 1/4 of 20? So here's my 20 dots, and I have them grouped in lots of 4. So if I do 1/4 of 20, here's one lot of 1/4, 2/4, which would be a half of them, so that would be 10, 3/4 would be 15, 4/4 would take up the whole lot. So 1/4 of 20 would be 5. So I think on our next screen, I've got some more like that. So what I'll be asking you to do is to find the fractional amounts. You can use blocks or counters to help you, or you can just do it in your head. So back to annotating, wing. Okay, so 1/5 of 20 we decided was 4. We can look at it the other way. 20 divided by 5 is 4. Don't like division? Michael, that could be coming back to your table facts. So you might want to think of it like this, 1/5 of 20. So instead of being put off by that divide sign, you might to think of, well, what's 1/5 of 20? And like we had back there before, you could do a grid of 20 dots. And the clue is to break them up into 5 at a time. And you'll notice that I've got 4 rows. And so I want 1/5. Sorry, let's go this way. I've got 5 columns. So if I want 1/5, I want 1 column of those. So you might like to go with the approach or using counters rather than thinking about division. Okay? So some people will intuitively know that a quarter of 12, how many 4s in 12, that's the same way as saying it. So a quarter of 12 will be 3. So you might need to think about drawing a diagram or having some counters in front of you to do that. So I've left so these are all just, 1/5 or 1/9, but we can use that information in order to find more fractions of numbers. So once we know how to find one part of a group, we can use it to find other amounts. So 2/3 of 9, first of all, we better find 1/3 of 9, and 1/3 of 9 is 3. So therefore 2/3 of 9 is going to be 2 lots of 3. So 2/3 of 9 would be 6. So you could count it like 3, 6, 9. So here's 1/3 of 9 is 2/3 of 9. So just some ideas to think about with fractions. Move on to the next one. Oh, so that's all I've got for you on fractions. So hopefully you can have a go at that. I'm aware of the time and we might just run a little bit over, but that's okay. I did start 5 minutes late. So data, we've also been looking at data. Jacob's been doing a fair bit on tally tables and that sort of thing. So let's just have a look. Here are 3 kids who are about the same age as you. Look at their answers. What questions were asked? So here we have a table. And as I said, this will be on your sheet, and you'd need to write in here, what sort of question do you think was asked in part A to end up with the answer of spaghetti, hamburgers, and chocolate? What did they ask? Feel free to turn your mic on if it's easier, because sometimes it takes a long time to type out your answer.
Carrie, for the first one, I reckon it's what did you have for dinner? Oh, sorry,
hang on.
I didn't mean
hang
to
on.
be talking.
What is
Michael,
your favourite food?
Yeah, what's your favourite food? What's your favourite food, Jacob?
My favorite food is broccoli. I'm not joking about this. I love broccoli.
Wow, baby trees.
Yeah, baby trees. I think they're very cute.
Yeah, I don't know what my favourite food is. I do like cheese.
Uh,
All different types of cheese. So,
Aiden, did you want to have a question to get those results?
could have been, what did you eat for dinner last night?
That's what I thought.
Yeah, Max just ate chocolate.
Well, I've been Max before.
Okay. All right. So I think, so I don't know that you could really come up with the wrong answer there. So we'll get you to write some things in there when you get it. So a movie theatre collected data on the number of kids and adults that attended a recent movie screening. A kid's ticket is all ages up to 15, and adult's ticket is 16 and above. Too bad if you're 16 and still at school. Count how many kids' tickets and how many adults' tickets were sold using the tally method. So here's the ages of people. So I'm just going to turn on my little annotating thing here, here, and I'm going to cross them off as I go. So 40, they're definitely an adult. And 12, they're a kid. And 19, they're paying an adult price. 42, they're paying an adult price. So notice that I just don't go through and count all the adults and count all the children because it's very easy to get lost in those. So I'm just going to keep going because I can see what's going to happen here. I've got another adult, they're 36, and this other adult, 25. Remember, when we do a tally table, we don't put 5 in a row. We cross them because it's easier to see. So I'm going to have you complete a tally table for that. And why do you think they conducted this survey? And I'm not going to talk about that now because it's something, sometimes you need think time. So I'll get you to have a think about that. Lots of reasons why they might have asked that survey. But again, I don't think you can get the wrong answer on questions like that. Column graphs. I like column graphs to be separate. So this is really sort of like a histogram, I suppose. Column graphs are a clear way of showing and comparing data. There's a horizontal line as the different categories, and it looks like that's months. And we also have a vertical axis, and this looks like the number of children, and it has a title. This is the birthday months at school. So if I was to add to this, I would be in February because my birthday's in February. Where would yours sit, Aidan? And Michael, where would your birthday sit? Aidan's in December, so you'd be down here somewhere, so you'd be making up that part. And Michael's is in January, so you've had, like me, you've had your birthday, Michael. We're done for the year. What about you, Jacob? Where would you sit? I don't know where Jacob's sitting.
Sorry, Carrie, I missed a question.
Oh,
I'm
that's
still
all
here.
right. Just wondering when your birthday was, where you would be sitting on this chart.
I'm a Pisces, so I'm in March.
Oh, you're in March. Oh, it's coming up. How exciting. So
Yeah.
I can see from this, because I've got a proper scale here, it goes up by 5, 10, 15. So it goes up by 5s. Most people are having a birthday in September. So how many birthdays are there in the first 3 months of the year? So I need to be looking at January, February, March, and I need to check the scale that I have on the side. So I've got 5, 10, 15, 20, 25, 30, 35. So it's just another way of counting by 5s, or you could have said 10 plus 5 plus 20 to get to 35. So one of the skills we want you to have is to be able to interpret graphs. So I'll be sending that one out too. Nearly done. Bar charts, column graphs on the side. So this time the horizontal line has a scale and the vertical axis looks like the number of treats bought for the fete. So they're buying cheesecake, vanilla slice and chocolate crackles. I do love a chocolate crackle, to be honest. Write something that this graph shows you. So specifically, we're not asking anything in this case, but you can take out of that, you might want to write down 2 things, 3 things that you can see. Anything that you can put together, we'd be really interested to know what you're getting from that graph. So I'm going to be emailing that to a few of the kids in my class, particularly, you guys will be getting it. And my last slide is a share slide because clubs are coming and the first virtual hangout session, I think this is for 7 to 10. I don't know. I was asked to share it, but certainly on March the 5th at 3:15, you can find out about all of these clubs. You might be interested in Dungeons and Dragons or Environment Club or Minecraft. There is a link that you can go to. I'm sure that there'll be something if you ask your learning advisor, they might be able to help you.
Oh, sorry. There's
Go
also a
ahead.
high probability that there'll be a horse club because
Oh, wow.
there are so many horsey people at our school.
Yep.
Yep.
Fabulous.
I
Well,
know.
that's where I'm going to end the lesson today. I'm hoping that people will enjoy and come back to the recording. Give us your feedback on the level or the pitch if you need something easier or harder. But we'll be sending that through, and I'll be back on Tuesday to do some more support. So thank you for coming along, and I'll ask Jacob if he can stop the recording. And the chat will still be open if anybody wants to say goodbye. That would be nice. So I'm going to say bye.